So today in our lab, we're going to be measuring things under the microscope. Okay? And we need to talk a little bit about some units that we use and how we actually can measure an object as we're looking at it under the microscope. So first of all, as you know from what we talked about yesterday, that circle that we see under when we're looking in the microscope, it's called our field of view or field of vision. And we can measure, when we look through that microscope, how wide our field of vision is, right, in an area of length. So field of vision is the area we see in our microscope. It's a circle. And so often what we look to measure is the diameter of that field of view. And if we know the diameter of the field of view, we can then estimate how big various objects that we're seeing are. Okay, the units that we're going to use are a unit we have not talked about before. They're called micrometers. A micrometer is a millionth of a meter. In 1 single millimeter, those smallest lines on our rulers and meter sticks, there's actually 1,000 micrometers in each millimeter. So a micrometer is obviously quite small. So 1 millimeter equals 1,000 micrometers, or if we say it inversely, 1 micrometer is 1/1000th of a millimeter. So when we're converting, which you will have to do from millimeters to micrometers, going from millimeters to micrometers, how many places do you move the decimal? 3 to the right. 1 millimeter, 3 to the right to get to micrometers. From micrometers to millimeters, what do? 3 to the left. Okay? So, again, those are your key conversions to know. And so we can actually measure the field of view in the microscope. It's not too difficult. One way that we can do that is we take a clear plastic ruler like this. Okay, it has centimeters and millimeters marked on it. We place a metric ruler that's clear on the microscope and look at it, you might see something like this. And so if I did that and say under 60x magnification total, what's the diameter of my field of view?
6,000.
6 what? Veggie burgers? No.
6 millimeters.
I hear different things.
6,000 millimeters.
Or
6 millimeters.
correct. So 6 millimeters. Okay, each numbered line is a millimeter. So it's 6 millimeters across, or that is equivalent to 6,000 micrometers. Today we are going to be looking at some millimeter graph paper under the microscope. Millimeter graph paper is called millimeter graph paper because between each line it's 1 millimeter length. So if I were looking at some graph paper under the microscope, some millimeter graph paper, how wide is the diameter of that field of view? Raise your hand, please. Julia?
6.
6 what?
I don't know, like millimeters.
No. The diameter of the field of view. Bella?
4 millimeters.
No.
Oh,
Oop.
5.
5 millimeters. So why 5? I go across the middle. The diameter is right across the middle. That's 1 millimeter, 2 millimeters, 3 millimeters, 4 millimeters, and 5 millimeters. Okay, so that's 5 millimeters across. So, do I count spaces or lines?
Spaces. Spaces is 4 lines. Spaces. Squares.
What is a millimeter? Is it the line?
No.
No, it's the distance between two lines. So this is 1 millimeter. This is 1, 2, 3, 4, 5. If I were just to count lines, 1, 2, 3, 4, because really this next line is right there at the edge. We don't see it because it's off the screen, but that would be 5 millimeters or 5,000 micrometers. If I zoom into 110x magnification and I see this, what's the field of view? Is it? This is 1 millimeter. So is it exactly 1? No, I have a little spot on each side. Again, something you would have to estimate. What about 1.2 or 1,200 micrometers? So once we know this, we can use our known diameter of the field of view to estimate the size of objects. And here's an example, not involved with a microscope. We call this indirect measurement. Okay? So if we know the height of this tree is 6 meters, okay, we can figure out how tall Mr. Arcuri is. Okay? Because what we do is we say, all right, how many Mr. Arcuris would you have to stack up to reach the top of the tree?
2.5.
2.5? Yeah, about 3. So how tall is Mr. Arcuri in comparison to the tree? No.
Very short. 3 meters.
He's what?
3.
1/3 is 1/3 of the tree's height. So how tall is Mr. Arcuri? 2 meters. 1/3 of 6 meters is 2 meters. So the same principle holds true for looking at things in the microscope. If I've measured this field of view to be 10 millimeters, what's the width of this organism? Yeah, about 5 millimeters. Again, these are estimates. They're not exact, but takes up about half of the field of view. And so therefore, half of 10 millimeters is 5 millimeters. How many micrometers? 5,000. Okay? Here, I have a different field of view. I must be on a different power. It's 4 millimeters. Yeah, so this is about 1 millimeter, or 1,000 micrometers. On the top?
6.
Well, it depends if you're including his arms, right?
Well, he's going like this with his
So we're going to include his arms. Let's say he takes up the whole field of view. It's 8 millimeters, 8,000 micrometers. How about this one?
2.
Yeah, that's about 1/3, right? It's more than, you could fit probably 3 across, right? Yeah, that's about 2 millimeters, 2,000 micrometers. How about this one?
3.
3?
No,
Yeah, maybe, if you're not including the tail. What about Cookie Monster?
5.
About 5.
6.
Probably fit 4 of him across. He's 1/4 the field of view. 1/4 of 20 is 5, or 5,000 micrometers. So you're going to be doing this today and tomorrow as we use our compound microscopes. It's really not complicated.
Are we going to be working on our labs too?
Yes.